Now, I will reveal one of the most guarded secrets of history. We all use roads every day, but we rarely think about how long they will last. 50 years. What if I told you that some roads built 2,000 years ago are still in use today? Ancient Rome created not just pathways, but an engineering marvel that survived the empire itself. These stone arteries stretched across the continent, from foggy Britain to the sands of Syria. They withstood millennia of wars, oblivion, and the onslaught of nature. The Romans had neither excavators, nor asphalt pavers, nor laser levels. Their strength lay elsewhere. They transformed simple construction into a science based on brilliant calculations, an understanding of materials, and incredible organization. Watch the video to the end, and you will learn how Roman engineers managed to build perfectly straight roads through mountains and swamps, and what secret component in their foundation allows these roads to serve us, even in the 21st century. What if I told you that the famous Roman roads weren't built just for the convenience of travel? Their true purpose was far more important and strategic than simply getting from one city to another. The Romans thought in terms of control, power, and speed, not private comfort. A road was a tool for conquest and empire control, the steel skeleton that held all their power. Each mile paved with stone was a statement that this land belonged to Rome, and it would always belong to Rome. This network was the artery through which the will of the emperor flowed. The primary goal of this grand network was speed, the speed with which legions could be moved to any point in a rebellious province. Before these roads, an army's march was slow and dependent on weather and terrain. Now soldiers could move with incredible speed, covering dozens of miles a day, regardless of weather conditions. This was a true military revolution, allowing Rome to control vast territories with relatively small forces. The road was a weapon more formidable than any sword or spear. It provided a strategic advantage that no enemy could dispute. In addition to the military aspect, roads carried a powerful ideological charge. Every new highway built was a visible embodiment of Roman order and civilization. For conquered peoples, it was a daily reminder of who was in charge. Rome didn't just conquer, it fundamentally changed the landscape, bending it to its will. These straight, arrow-like lines cutting through wild terrain demonstrated Roman engineering genius's supremacy over the chaos of nature. Building roads was an act of propaganda carved into stone. Although not the primary focus, the economic component quickly became one of the most important consequences. The creation of reliable communication routes gave an incredible boost to trade. Goods that were once too costly to transport flooded the empire. Olive oil from Spain, wine from Gaul, grain from Egypt, all of these flowed along stone arteries, enriching the treasury and tying the provinces into a unified economic space. Cities located at the crossroads of these roads turned into thriving hubs. The road became the circulatory system of the imperial economy. We should also note the unique state postal system known as the cursus publicus. This service was only available to government officials and couriers with special permission. Along the roads there were stations called mutationes, where horses could be changed, and mansiones, where one could stop for the night. This system allowed imperial decrees and reports to travel across the empire at an incredible speed. The road became not only a path for soldiers, but a conduit for information. Roman roads were a multifunctional system unmatched in the ancient world. They weren't built haphazardly. They were part of a grand master plan. Each major road had its name, often in honor of the censor or emperor who commissioned it. The most famous of them, the Appian Way, was rightly called the Queen of Roads. It set a standard that engineers followed for centuries. This approach demonstrates the Romans' systemic thinking, their ability to plan for centuries ahead. Surprisingly, the Romans preferred to build roads straight, regardless of obstacles. If a hill stood in their way, they didn't bypass it. They cut through it. If there was a swamp, they drained it or built embankments. This principle of the straight path was another manifestation of their philosophy of dominance over nature. It required colossal engineering effort, but the result was worth it. The shortest distance between 2 points saved precious time for the legions. I'd be very interested to know your point of view. What do you think in the modern world fulfills the same role of demonstrating power and technological superiority as the roads did in Rome? Write your thoughts in the comments and be sure to subscribe to the channel so you don't miss our next investigations. Guess how they could lay out a perfectly straight line for dozens of kilometers through forests and hills without satellites or lasers? What Roman surveyors, or grammatici, did may seem like magic, but in reality, it was a precise science. They had simple but incredibly effective tools at their disposal. Their work was the first and one of the most important stages in the entire construction process. A mistake at this stage could nullify all subsequent efforts. The main tool of the grammaticos was the groma. It was a wooden pole with a horizontal crosspiece at the top. Plumb lines hung from all four corners of the crosspiece. By inserting the pole into the ground and ensuring the plumb lines hung motionless, the surveyor could precisely mark straight angles. Using a system of landmarks, long poles driven into the ground, the surveyor team could shoot a straight line from many kilometers ahead. For determining the level horizon and the slope of the land, another tool was used, the corabat. This was a long wooden beam, about 6 meters, with plumb lines on the sides and a groove for water on top. If the plumb lines lined up with the marks and the water in the groove stood still, the instrument was perfectly horizontal. This tool was indispensable when building aqueducts, but also for roads that required precise slopes for water drainage. It was critically important. A more complex tool was the dioptra, a kind of ancient theodolite. It allowed for both horizontal leveling and angle measurements. This was necessary in mountainous terrain to calculate the optimal slope for ascents or descents. Roman engineers tried not to exceed certain slope values so that heavy carts and military machines could travel without problems. Working with the dioptra required high qualifications and mathematical knowledge. The layout process began with selecting key points on the route. Architect engineers determined the start and end points of the road and the main cities it should pass through. Then, the grammaticoi started their work, laying out the course between these points. They tried to keep the line as straight as possible, but sometimes they deviated to avoid large swamps or use convenient river crossings. Still, the drive for a straight line was dominant. Once the main direction was set, detailed marking began. Using the grommet and landmarks, the precise axis of the future road was determined. Pegs were driven in on either side of it, marking the width of the roadway. For major imperial roads, this width was strictly standardized to allow 2 carts to pass each other. This standardization was another characteristic of the Roman approach to construction. Surveying was incredibly difficult work. They had to hack their way through dense forests, climb hills, and work in any weather. Often, legionary units preceded them, clearing the way and providing security. Surveyors were pioneers, the first to go where civilization would soon appear. Their calculations had to be flawless, as their markings would guide thousands of workers. After the route was marked on the ground, detailed plans were drawn up. These plans, though few have survived, formed the basis for all subsequent work. They indicated not only the direction, but also necessary engineering structures: bridges, embankments, cuts. Architects and engineers calculated the earthwork's volumes and the materials required. It was an incredibly complex logistical and managerial process. Do you think modern technology has completely replaced the skills of ancient surveyors? Or is there still room for intuition and experience in this work? In the next chapter, we'll literally look inside a Roman road. Ready to learn what multi-layered pie makes them almost eternal? I will reveal the most guarded secret of Roman engineers, which allows their roads to serve us today. The secret is not a single magical material, but the obsession with one simple idea. This idea was the battle against the main enemy of any construction: water. Roman engineers understood that if water stagnated, it would destroy even the strongest foundation. Therefore, the entire road construction was essentially one gigantic and very complex drainage system. This, not just the strong stones, is the key to their immortality. The construction began with digging a wide and deep trench, or fossa. Its depth could reach 1.5 meters, depending on the soil. This was not just digging, it was laying the foundation. Even at this stage, drainage was laid. The bottom of the trench was often compacted and sometimes even covered with a layer of sand. On both sides of the road, deep drainage ditches were also dug to drain all moisture. Next, the first layer of foundation, called statumen, was laid at the bottom of the trench. It consisted of large uncut stones, the size of a fist or even larger. These stones were laid as tightly as possible, creating a solid and, importantly, porous base. The gaps between the stones allowed any water, seeping from above or rising from below, to freely flow into the drainage ditches. This layer was the first barrier against destructive moisture. On top of the statumen, a second layer, rudus, was piled. It consisted of smaller stones, gravel, or even broken brick mixed with a small amount of lime or sand. This layer was carefully tamped and leveled. Its task was to fill the voids of the previous layer and create a smoother, denser surface for the subsequent stages. The thickness of this layer was also considerable, adding overall strength to the road. The third layer, nucleus, or core, was almost the final one. It was a kind of ancient concrete. It consisted of fine gravel, sand, and a large amount of lime. This mixture was laid hot or wet, and it solidified into a hard, waterproof slab. This layer was key to waterproofing. It prevented rainwater from seeping into the lower layers of the foundation. It was the nucleus that largely ensured the preservation of the foundation. Finally, the road surface itself, pavimentum, or summum dorsum, was laid on the nucleus. On the most important roads, like the Appian Way, these were large, perfectly fitted polygonal slabs of solid basalt or lava. The seams between them were so small that a knife could barely pass through. On simpler roads, smaller stones, gravel, or even compacted gravel mixed with lime could be used. But that's not all. The road surface itself was not flat. The Romans made it slightly convex with a slope from the center to the edges. This sloped shape, known as agger, was a brilliant solution. Thanks to it, rainwater didn't stagnate on the surface but immediately flowed to the shoulders and then into the drainage ditches. The road essentially drained itself. This principle is still used in modern road construction. This multi-layered construction was not only incredibly durable, but also flexible. It could withstand enormous loads from heavy carts and marching legions. At the same time, the different layers distributed the load in different ways, preventing the road from sinking or breaking apart. It was a true engineering masterpiece where each element served its clear function. The thickness of this pie could vary, but on main highways it often exceeded 1 meter. This made the road not just a surface, but a full-fledged and massive structure. It was so firmly embedded in the landscape that it was easier to use it as a foundation for a new road than to try and dismantle it. This is why many modern European highways exactly follow the routes laid by the Romans. This unique technology was the result of centuries of experience and experimentation. The Romans were not afraid to try new materials and combinations, perfecting their construction to the highest level. They created a standard so successful that it couldn't be surpassed for 1,500 years. It's a clear example of how a deep understanding of material physics and the surrounding environment can lead to eternal solutions. If you enjoyed this story about the hidden secrets of Roman engineers, don't forget to like the video. It really helps us create new episodes. Also, make sure to subscribe to the channel so you don't miss new videos where I talk about the secrets of ancient Rome. Are you ready to learn the truth about what incredible effort it took to build even 1 mile of Roman road? We admire the technology, but behind it was a logistical operation comparable in scale to a military campaign. Moving millions of tons of stone, sand, and lime required flawless organization. Each road wasn't just a construction site, it was a huge industrial project. The Roman administrative machine worked like clockwork, ensuring this conveyor kept running. The first task was finding and developing quarries. Engineers didn't just take stones lying on the surface. They searched for specific rocks with the required strength and durability. For the top layer, they preferred solid basalt or lava. For the lower layers in concrete, limestone was needed to produce lime, as well as gravel and sand in massive quantities. Often, quarries had to be opened from scratch in the wild. Once a quarry was found, extraction began. Thousands of workers using primitive tools, pickaxes, wedges, and hammers extracted stone blocks. It was a tough and methodical process. The blocks for the pavimentum required further processing. They were trimmed into shape to fit perfectly together. This process required highly skilled stonemasons who were worth their weight in gold. The most difficult task was transportation. If the quarry was far from the construction site, the materials had to be moved. They used heavy carts pulled by oxen. This was a slow and inefficient method. Therefore, the Romans always tried to use water transport whenever possible. Stone was loaded onto barges and floated down rivers as close as possible to the construction site. This significantly reduced costs and sped up the process. Logistics required not just transportation, but also infrastructure. Temporary roads had to be built to carry materials from quarries and river docks to the main construction site. It was also necessary to organize the supply of workers. They needed food, water, tools, and housing. Entire temporary settlements would often spring up around large construction sites. The organization of work on site was another miracle of Roman administration. Construction wasn't done haphazardly. It was broken down into sections, each of which was managed by its own team. Some dug the trench, others brought stones, some laid the statumen, and others prepared the concrete mix. It was a true conveyor belt where everyone knew their task precisely. The military discipline brought by the legionaries was key to such efficiency. To prepare the concrete used for the nucleus layer, a huge amount of lime was required. Lime was produced by burning limestone in special kilns. These kilns were built right on site, using wood as fuel. This meant that entire forests were often cleared around the construction site. Roman construction drastically altered the surrounding environment, and this was one of the prices that had to be paid for eternal roads. The Romans were masters at using local resources. Although the construction standard was uniform, engineers adapted it to available materials. If basalt wasn't nearby, the top layer might be made from softer sandstone or even baked brick. If stone for rudis was lacking, broken brick or ceramics were used. This flexibility allowed roads to be built throughout the empire, in the most varied geological conditions. Which part of this grand logistical process seems the most challenging to organize? In the next chapter, we will talk about those who built it all with their hands. Behind every great construction is a person. In the case of Roman roads, these were not just nameless workers, but well-organized and highly motivated teams. The empire's primary construction force was its army. Roman legionaries were not only top-notch soldiers, but also highly skilled builders. In peacetime, when there were no campaigns, the army was never idle. Construction was one of their main tasks. A soldier sitting idle was considered a danger in Rome. Therefore, generals and emperors always found work for the legions. Road construction, bridge building, aqueducts, and defensive walls were all part of their direct duties. This practice had a dual benefit. The country received necessary infrastructure, while soldiers maintained their physical fitness, discipline, and were kept constantly busy. A legionary with a pickaxe in hand was as much a symbol of Rome as one with a sword. Of course, not all soldiers were engineers. Most did heavy physical labor, digging, carrying stones, tamping down soil. But every legion had its own engineering corps, the fabrica. These were highly skilled specialists, surveyors, carpenters, stonemasons, blacksmiths. They managed all the complex tasks, performed calculations, designed bridges, and ensured quality construction. These people were the true technical elite of the ancient world. In addition to legionaries, auxiliary troops, auxiliaries, were brought in for construction. These were soldiers recruited from non-Roman provinces. They did the same work as legionaries, building roads in their own lands. This also had an ideological meaning. Conquered peoples participated in building the infrastructure that bound them to Rome. We also need to mention the enormous labor resources that were brought in from outside. For the construction of particularly large projects or in cases of insufficient soldiers, the authorities could use forced labor from the local population. Slaves were also used for the toughest tasks, such as in quarries. However, the foundation of the entire process was the organized and disciplined work of the military units. The organization of labor was structured like the military. Workers were divided into centuries, each led by a centurion. Each group was responsible for its section of the road. There was a clear division of labor and a strict hierarchy. This allowed coordination of the efforts of thousands of people, achieving maximum productivity. This approach was unimaginable in any other ancient society. In the end, the Roman road is not only a monument to engineering thought, but also to human organization. It would have been impossible without the legionary, who could wield both a sword and a construction tool equally well. The army was the backbone that not only conquered the empire, but literally built it from scratch. What if I told you that Roman engineers saw no difference between building a road and building a bridge? When a river or deep gorge blocked the path of a straight road, the Romans didn't look for a detour. They simply crossed the obstacle. Their bridges and tunnels are a separate chapter in the history of engineering, demonstrating their will's absolute supremacy over any landscape. The secret of Roman bridges lay in one key element, the semicircular arch. The Romans didn't invent the arch, but they perfected its use to absolute perfection. The arch allowed them to span large distances while using relatively small blocks of stone. All the weight of the bridge and the carts passing over it was distributed through the arch onto powerful support piers, pylons. The construction of a bridge began with building the supports. If the river was shallow, workers diverted the water using temporary dams and built the pylons on solid ground. If the bottom was deep or muddy, the Romans used a complex technique. They drove 2 rows of wooden piles into the riverbed, creating a watertight caisson. Then they pumped out the water and mud, and in this dry space they built the stone foundation for the pier. For constructing the arch itself, wooden centering was used. These were massive semicircular wooden frameworks placed between 2 supports. Stonemasons then laid clinker stones for the arch on this framework as a template. The final stone placed at the top of the arch was called the keystone. Once the keystone was in place, the arch achieved its structural strength and the wooden centering could be removed. The Romans didn't build only with stone. They were pioneers in using concrete. Many of their bridges have a concrete core, clad with dressed stone. This allowed them to build faster and cheaper without sacrificing strength. The concrete they used was incredibly durable, largely due to the addition of volcanic ash, pozzolana. This component gave the concrete hydraulic properties, meaning it could harden even underwater. In addition to bridges, mountains stood in the way of the legions, and here the engineers did not hesitate. If the hill was not too large, they simply dug a deep trench through it, preserving the straight route. But if a mountain range stood in the way, they were ready to punch through it. Roman tunnels are one of the most impressive examples of their perseverance. Digging tunnels was an incredibly labor-intensive and slow process. Workers used pickaxes and wedges, literally chiseling through the rock centimeter by centimeter. To speed up the process, they often dug from both sides simultaneously. And to ensure that the 2 teams met at the same point in the middle of the mountain, precise geodetic calculations were required. Grammaticoi and dioptra were indispensable here. To break through particularly hard rocks, the Romans used the fire and water method. They built huge bonfires at the working face, heating the stone, then doused it with cold water. The thermal shock cracked the rock, making it easier to break. It was dangerous work, but it allowed them to progress where a pickaxe alone would have been powerless. Which engineering task seems more complex to you for the time? Constructing a multi-span bridge over a fast river, or drilling a tunnel through a rocky mass? And in the next chapter, we'll talk about how roads became the first global fast communication system. The roads were built for the legions, but very soon they took on a new, no less important function. They became channels for information transmission. In an empire that stretched across 3 continents, speed of communication was synonymous with control. To solve this task, a unique system was created, cursus publicus, or the public mail. This was not just mail, but a whole state transportation network. The founder of this system is considered to be the first emperor, Augustus. He realized that to manage such a vast territory, he needed reliable and fast delivery of decrees, reports, and messages. The cursus publicus was entirely state-run and financed by the treasury. Its services could only be used by officials, military personnel, and couriers with special permission, a diploma. This was a strictly guarded and privileged service. The entire system was built on the infrastructure of roads. Along the main highways, stations were built at strictly defined intervals. There were 2 types of stations. Mutaciones were small posts located every 10-15 miles. Here, a courier could change their tired horse for a fresh one and immediately continue their journey. These stations always had stablemen on duty and a large herd of horses. The second type of station, mansiones, was much larger. These were located a day's journey apart, about 25-30 miles. These were full-fledged inns where officials or couriers could stop for the night. They not only had stables but also food storage, smithies for transport repairs, and even small baths. Mansiones were the administrative centers of the road service. Thanks to this system, the speed of information transmission in the Roman Empire was phenomenal for the ancient world. A courier changing horses at each Mutationsi station could cover 150-200 miles in a single day in an emergency. In comparison, an ordinary traveler with a cart would cover no more than 20 to 25 miles. This meant that a decree from Rome could reach Britain or Egypt in just a few weeks. The system was divided into two subdivisions: cursus velox, fast, and cursus clivularis, heavy. The cursus velox used light two-wheeled carts or horseback riders and was designed for urgent letters and officials. The cursus clivularis used massive four-wheeled carts drawn by oxen and was responsible for transporting heavy cargo, such as state grain, money for the army, or construction materials. When the empire began to decline, one of the first things to collapse was this complex system. Maintaining stations and ensuring their safety became more difficult. With the decline of cursus publicus, the empire began to go blind. Information no longer arrived on time, and the center could no longer adequately respond to border threats. This shows that roads and communication were not just a convenience, but the very foundation of the Roman world's existence. Building a road was only half the job. To make it serve for centuries, it needed to be maintained. The Romans understood this perfectly and created the first road maintenance and navigation system in the world. The road was not just a strip of stone, but a living organism with its infrastructure. Without it, it would quickly fall into disrepair. The main element of navigation was the miliarium, or milestone. These were cylindrical stone columns, about the height of a person, set along the road every Roman mile. A Roman mile was 1,000 double steps, or about 1,480 meters. These pillars were not just distance markers, but true monuments. Each milestone had an inscription. It contained important information. First, the distance to the nearest major city, or to the Golden Milestone in Rome, which was considered the starting point for all roads. Second, and equally important, the name of the emperor or official who built or repaired this section of the road was marked. This turned infrastructure into a propaganda tool, glorifying the ruler. For travelers, these stones were invaluable. They kept them on track and allowed them to accurately calculate how much time it would take to get to the next settlement, or mansio. The network of milestones was so dense that getting lost on the main Roman road was almost impossible. This gave people a sense of security and order, which was sorely lacking in the rest of the world. In addition to milestones, there were other forms of navigation. At major road intersections, more complex signs were erected showing directions to different cities. There were even ancient travel guides, itineraries. These were lists of all cities and stations along a particular route, with the distances between them. These were the first road maps, though in text form. But no navigation would help if the road was in poor condition. In Rome, there was a special office called curatores viarum, or road supervisors. These were high-ranking officials, often from the Senate, who were personally responsible for the condition of major highways. They managed the funds allocated for repairs and oversaw contractors. Ongoing repairs were a constant concern. Roads wore out from the intense traffic of heavy carts and marching armies. Stone slabs could crack. Drainage ditches could become clogged. Special work brigades constantly patrolled their sections, filling in potholes, clearing the shoulders of vegetation, and checking the condition of bridges. This was a methodical, never-ending job. This system only began to fail with the weakening of central power. When the treasury ran out of money and officials stopped doing their jobs, roads began to deteriorate. Drainage became clogged, slabs came loose, and the paths gradually fell into disrepair. The Middle Ages didn't just fail to build new roads. It couldn't even preserve the old ones because it had lost the most important thing: the Roman system of organization. Although roads were originally built for the legions, their long-term effect was the complete transformation of the economy. Before this network, long-distance trade was extremely risky, slow, and expensive. Goods were either transported by sea, which was dangerous due to pirates and storms, or on dirt trails where carts got stuck in the mud. Roman roads changed everything. The solid and reliable surface allowed heavy-wheeled carts to be used year-round. The speed and cargo capacity of transport grew exponentially. What once took weeks now took days. This led to a sharp reduction in transportation costs. Goods that were once only available where they were produced could now be sold profitably thousands of miles away. This led to the specialization of entire regions. Gaul became known for its wine and ceramics, Spain for olive oil and metals, Egypt and North Africa for grain. All of these goods flooded into Rome and other major cities, creating a unified imperial market. The road connected producer and consumer as never before. Along the roads, new cities sprang up like mushrooms after rain, and old ones thrived. Any settlement located at the crossroads of trade routes instantly became a major commercial hub. Markets, inns, workshops appeared here. Roads were the arteries that brought life and wealth to these cities. Roads also contributed to the monetization of the economy. Long-distance trade required a unified and stable currency. The Roman denarius became the dollar of the ancient world, accepted from Britain to India. Along the roads, not only merchants traveled, but also tax collectors, who collected duties and taxes, filling the imperial treasury. Roads allowed Rome to effectively extract resources from the provinces. Safety on the roads was another key factor. Military posts and patrols were located along the highways to protect travelers from bandits. While it was impossible to completely eradicate crime, the level of safety on Roman roads was unprecedented for the ancient world. Merchants could send their caravans without fearing to lose everything along the way. Interestingly, the roads were free to use. Rome didn't charge for using the infrastructure as such. Taxes were collected in the form of duties on goods transported when entering cities or crossing provincial borders. This encouraged the free movement of people and goods. The roads also facilitated the movement of technologies. Craftsmen, architects, and doctors all traveled across the empire, sharing knowledge. If a new method for producing glass was invented in Syria, it quickly spread to Gaul thanks to the roads. This led to an overall rise in the technological level across the empire. This economic integration was one of the main reasons for the longevity of the Roman Empire. The provinces were connected not only by the fear of legions, but also by mutual economic benefit. The roads were the glue that held this vast and heterogeneous state together. When this system collapsed, Europe fell into the Dark Ages. Trade shrank to local markets, cities emptied, and the economy reverted to subsistence farming. It took over 1,000 years to restore the level of economic connectivity that Roman roads had provided. 2,000 years have passed. The empire has long fallen, and the languages spoken by its builders have become extinct. But the roads remain. Their legacy is not just a museum exhibit, but a living part of our modern landscape. Many of us walk and drive on them every day without even realizing it. What's most amazing is that so many modern highways in Europe and the Middle East are laid directly over Roman routes. When engineers of the 19th and 20th centuries began building new roads, they were surprised to discover that the Romans had already chosen the most optimal and direct path. It was easier and cheaper to build on the strong Roman foundation than to lay a new one. In countries like Britain, many famous roads such as Watling Street or Fosse Way exactly replicate Roman roads. The same can be said for many national roads in France, Spain, and Italy. The foundation laid by the legionaries was so durable that it still withstands modern truck traffic, requiring only new surface layers. Of course, not all roads have survived so well. Many secondary paths were abandoned when the empire fell, and the maintenance system collapsed. They became overgrown with forests, plowed by farmers, or dismantled for building materials. Medieval castles and churches were often built from stones that once lay at the foundation of Roman roads. However, even abandoned roads have not disappeared without a trace. They can often be traced through aerial photographs. Straight lines cutting through fields and forests give themselves away by small changes in the terrain or vegetation. Archaeologists use these ghost traces to map out the vast network created by Rome. Some sections have survived almost intact, becoming tourist attractions. The most famous example is the Appian Way on the outskirts of Rome. There you can walk on the same basalt slabs, that Julius Caesar and the Apostle Peter once trod. The feeling of touching this eternity is hard to put into words. These stones have witnessed the entire history of Western civilization. Roman roads set the standard for all subsequent generations of engineers. When the need for quality roads arose again during the Napoleonic era, and then in the Industrial Age, engineers turned to Roman experience. The principle of multi-layered foundations, and most importantly, effective drainage, was adopted as the basis of modern road construction. The legacy of Rome is not just laws, literature, and architecture. It is also the very idea of connectivity, the idea that vast spaces can and should be united by infrastructure. The Romans were the first in history to think in terms of a continent. Their road network was the physical embodiment of this global idea. They taught humanity that a road is not just a path from point A to point B. It is a tool of governance, an engine of the economy, a channel for culture, and a symbol of civilization. They built not for themselves, but for eternity. And, as time shows, they succeeded. Every time we drive down a smooth highway, we are, in some way, heirs of those Roman engineers and legionaries. They set the standard to which we still strive. And although our technologies have far surpassed theirs, the fundamental principles they laid down remain unshakable. Their work proves that truly great projects are those based on a deep understanding of nature, quality materials, and flawless organization. It is this approach that allows the creation of things that are not afraid of time. We conclude our journey through the stone arteries of ancient Rome. These roads are more than just stones and gravel. They are monuments to human perseverance, brilliant engineering thought, and incredible organizational skill. They show how infrastructure can create and sustain entire civilizations. The Romans built their roads with one goal in mind: to ensure the eternity of their empire. And although the empire itself fell, its roads have largely fulfilled this task, becoming the foundation for modern Europe. They have outlived their creators by millennia and continue to serve us, reminding us of the greatness of those who dared to think in terms of eternity. What other topics from ancient history or engineering wonders of the past would you like us to explore in future episodes? Perhaps you're interested in aqueducts, the Colosseum, or the secrets of the Egyptian pyramids. Leave your suggestions in the comments. And don't forget to subscribe to our channel so you don't miss new exciting stories.